Children, our next chapter, acids, bases and salts. See, I will discuss very important topics, children, here. So, what is the chapter name? Second chapter. First chapter is over. Chemical reactions and equation. Here, acid, bases and salts. So, one more question, children. Acids. What are acids? Acids, they are chemicals when dissolved in water liberate H plus ions or hydrogen ions, which are positive ions. Take for example acid, which is that acid we discussed, HCl. When dissolved in water, what do children? They liberate H plus ions or hydrogen ions. Similarly, which is another inorganic acid, H2SO4, when react with water, what do they give us? They give us hydrogen ions. Two hydrogen ions because it has got H2. As are no children. Then phosphoric acid. Phosphoric acid H3PO4 plus water. What do they give us, children? 3 hydrogen ions. That's it. One more question. What are acids? Chemicals when dissolved in water liberate H plus ions. HCl gives 1 hydrogen ion. Sulfuric acid gives 2 hydrogen ions when dissolved in water. Phosphoric acid, whose formula H3PO4, it will liberate 3 hydrogen ions. See. Next topic, children. Properties of acids. Properties of acids. Before we discuss that, we should know about indicators. A small topic. Indicator in acid, bases and salts. What are indicators? See, name itself tells us. Name itself indicates or tells us whether a given chemical is acid, base, acid or base or neutral. So what are indicators? Indicators are chemicals. See, we are familiar with this one, isn't it, children? We have indicator lights in our automobiles, like 2-wheelers and 4-wheelers, isn't it? When we are going in a straight road, suddenly we want to take right turn or left turn, we show the indicator. Indicator is there in 2-wheelers and 4-wheelers. When you switch on the light, it tells us the vehicles coming behind whether we take left turn or right turn. Similarly, indicators in chemistry or chemicals, they tell us whether given compound is acid or base. So, indicators are of how many types? There are 3 types of indicators. What are they? Litmus paper. Litmus paper. How big is children? Is the size of this point finger. Point finger. 3 inch. 3 inch size. Litmus paper. It is of one finger, point finger size. 3 inches. Understood? They appear in 2 different colors. What are they? First one, blue. Second one, yellow color, children. For example, see here. What it is? This is the test tube. I take some chemical. I label it as A. I take another test tube. I'll put some chemical. Now you have to tell me which is acid, which is base. Which is acid, which is base. Understood, children? See, what do you do? First dip a litmus paper in this. How much portion? This much portion is dipped in test tube, isn't it? In the chemical. So which is the color of this litmus paper? Blue. Blue paper. Blue litmus paper. What happens, children? See, children, I have dipped blue litmus paper in test tube A. Now you have to tell me whether it's an acid or base. See, this much portion is dipped in chemical. As are my children. This much portion, what happens? It changes to red color. This much portion turns to red color. So litmus paper, when dipped in a solution containing acid, blue turns to red. What does it indicate? Blue turns to red. Oh, sorry, children. I written it as yellow here. It's not yellow. It is red. What happens, children? Blue color turns to red. What does it indicate? It indicates that the given chemical is acid. So A stands for acid. Chemical in the test tube is what? Acid. Similarly, come here children. Again, take another litmus paper. Take another litmus paper. What is that? Blue color. Take red color. Red color. Here, what happens to blue color? This is test tube. Test tube. What happens to this blue color? Blue color litmus paper. Blue changes to red. This much portion. It indicates that chemical is acid. Come here children. Litmus paper dipped in chemical. Test tube containing chemical. This much portion. What happens? Red color turns to blue. Red color turns to blue. What does it indicate children? This chemical is B. B stands for base. That's it children. Litmus paper. What it does? It changes acid turn blue litmus paper red, bases turn red litmus paper blue. Understood children? That's it about litmus paper. Which is the second one? You can pause my video and get your concept clear. Which is the second one children? Methyl orange. Methyl orange is the second indicator. Methyl orange. As the name itself indicates, it's an orange in color, methyl orange. What happens? That are methyl acids. What the action of acids on methyl orange? What happens to acids? Acids turn methyl orange. Methyl orange. What do? They turn methyl orange red. Or easy topic children. One mark question. It will come in MCQ or 1 mark question. Definitely it will come. Therefore, I will discuss only important topics since less time is left. Acids turn methyl orange to red color. Bases. What happened to bases? Bases turn methyl orange. What do they do to methyl orange? Methyl orange, they turn to yellow color. What the action of acids on methyl orange? They turn red. What the action of bases on methyl orange? They turn methyl orange color to yellow. Second indicator children. Third one and last one, phenolphthalein. So how to pronounce phenolphthalein? Be careful while writing, pronouncing and writing. Phenol, P-H-E-N-O-L, phenolphthalein, P-H-A-L-E-I-N children. What the color of this phenolphthalein? It is basically colorless solution. What is that? Colorless solution. Understood? What is its action on acids children? What is its action on acid? Acids, what do they do to phenolphthalein? Colorless, remains colorless. It is colorless basically. When you put it in acid, it remains colorless only. So what does it indicate? The given chemical is acid. Then come to base children. Base. What base? What is the action of base or phenolphthalein on phenolphthalein? Phenolphthalein basically it is colorless. It changes to what color children? Pink. That's it. It changes to pink color. Understood children? Bases turn colorless pink. Acids turn colorless remains colorless. Bases turn colorless phenolphthalein to pink. This is about indicator children. Properties of acids. Our next topic children. Again, small topic, scoring topic. What are the properties of acids? Acids, they are sour in taste or sour to taste. Acids are soaring taste. Then we discussed about indicators, no children, that are blue litmus, they turn blue litmus red. Phenolphthalein, colorless, remains colorless. They remain colorless, remains colorless. Fourth point, children. What the fourth point? Third indicator. Litmus, phenolphthalein, methyl orange. They turn methyl orange, yellow. See children, what we discussed, indicators, same thing we are writing in properties of acids. Yes or no children? So, they turn methyl orange, yellow. Then last point. So, is it clearly visible children? I think it's not clearly visible. I'll write it again with the new pen. Okay now? Yeah. What the first point? They are sour to taste. They are sour to taste or sour in taste. They turn litmus paper. They turn blue litmus red. Then third one. What the third one? Phenolphthalein, colorless, remains colorless. What about fourth point children? That are methyl orange, yellow. Fifth point, they conduct electricity. Important point you should write children. They conduct electricity in aqueous form. Aqueous form is they require water, so that hydrogen ions are liberated and they conduct electricity. See children, they will ask you to write 2 to 3 properties. Write 2 properties of acids or write 3 properties of acid. Write properties of acids any 2 marks. Write 3 properties of acids any 3. They put in the bracket 3 marks. If you are lucky, they may ask it for 4 marks also, but definitely it will come. Children, next topic, reactions of acids. What reaction? Chemical reaction. What we discuss properties children is the physical properties. We discuss physical properties of acids, isn't it? They are sour to taste. Then we discussed about 3 indicators, action of 3 indicators on acids. Then they conduct electricity in aqueous form. These are all physical properties. Here discussing about reaction. What type of reaction? Chemical reactions with acids. Understood children? There are 5 important reactions. What are they children? Reactions of acids with metals. Any metals react with acids, what do we know? Already we discussed in first chapter, they liberate hydrogen gas. Yes or no children? Then that's what I said. If you understood the first chapter, next 2 chapters you understood 80%. That's why I highlighted again and again in the first chapter, chemical reactions and equation. Whenever the metals react with dilute acids, what happens? they liberate hydrogen gas. Then children, metal oxides, reactions of metal oxides with acids. What happens? Metallic salt and water is formed. Second, third one, reaction of acids react with bases to form salt and water. We already discussed in first chapter. During the beginning topics also we discussed. Then reactions with metal carbonates and metal carbonates. We'll discuss it now one by one. Before that, just a small trick I'll teach you children. See here. Now, metal oxide, metallic oxides, then metallic hydroxides, it will help you a lot children. Metallic carbonates, metallic bicarbonate, What is their nature children? See children, look at the board. Metallic oxides, metallic hydroxides, metal carbonates, metal bicarbonates, they are all are basic in nature. Finish children. If you know this, you yourself will write the reactions of acids with these things. Please pause my video, go through this point and get your concepts clear. Finish children. If you know that metallic oxide is a base, metallic hydroxide is base. Already we know hydroxides are bases. Metallic carbonates are also bases. Metallic bicarbonates, they are also bases children. All are bases. Now tell me children, take for example metallic oxide, sodium oxide, calcium oxide or potassium oxide, which are bases. If they react with acid, what's the end product? Salt and water. Yes or no? Then we already studied acids react with bases, hydroxides, to give salt and water. Metallic carbonates, bases. Again, when they react with acids, what the end product? Salt and water. What the action of metallic bicarbonates, which are bases? Again, they react with acids to liberate what children? To form salt and what? Not liberate. Understood children? Now we will discuss one by one. Please pause my video and get your concepts clear. Reactions of acids. First one is what children? With reactions of acids with metals. See children, already we discussed in the first chapter. We are discussing now. Next chapter is metals and non-metals. There also we discussed. That's why I said chemistry is the easiest topic. If any student loses even half mark or 1 mark, I will be that most disappointed person as a teacher, because you cannot afford to lose marks. Understood? Yeah. Come here. Acids, HCl. We write AQ, aqueous. Aqueous means containing some amount of water. Obviously it is dilute. HCl reacts with sodium. See children, what type of reaction? Displacement reaction. Yesterday we discussed. So compound reacts with element. What do we get? Hydrogen gas is liberated. See, n number of times already we discussed and we will discuss in the next chapter also. What's the product? Sodium chloride. Whenever acids react with base, acids react with not with base, children, metal, that's element. What happens? Hydrogen gas is liberated because sodium goes and displaces less react to element or metal. Hydrogen is a metal as well as non-metal. See, sodium being at the top of the reactivity series, more reactive than hydrogen. So it displaces hydrogen from acid and it occupies the place of hydrogen to form sodium chloride and hydrogen. This is the first reaction of acids with metals. Hydrogen gas is liberated. Yes or no children? See, now beauty of this chemistry asset. Second reaction is what? with reactions of acids with metal oxides. Metal oxides. First reaction was what? Reaction of compound with an element. Here, sodium oxide. What the formula of sodium oxide, children? Na2O. Valency of oxygen is 2. That's why it is Na2O. Here it is same thing. What's that? Aqueous HCl. Sodium oxide. Now, does it liberate hydrogen gas? No, children. Hydrogen gas is not liberated because it is not element now. Compound reacts with compound. Hydrogen gas is liberated by acid. But this suddenly it combines with oxygen or sodium oxide. Now, to form water. What is this? See now, sodium oxide, just I told you previous one, metallic oxides, metallic hydroxides, metal carbonates, metal bicarbonates, they are all basic in nature. Acids react with base to form salt and water. Yes or no, children? That's it. Take another acid. Take another acid. H2SO4. H2SO4 reacts with what, children? Magnesium oxide, MgO, because valency of magnesium 2, oxygen is also 2. So what is the product form, children? MgSO4, magnesium sulfate plus water. Take any metal, it combines with sulfate ions of sulfuric acid or chloride ions of HCl to form chlorides and sulfates. No need to go in deep, children, because it's a small topic, 1 mark question. Okay, because question will come, mention 2 reactions of acids. You can write any one of these 2. Again, I am discussing third one. Third one is what, children? Third one is what? Metal carbonates. Metal carbonates. Reactions of acids with metal carbonates. Reaction with metal carbonate. What is that? HCl. HCl, AQ, aqueous form. Then H2SO4 with aqueous form. Understood, children? Then you can write H3PO4. H3PO4. What that? Phosphoric acid. Understood? Yeah. What happens? They react with carbonates. They react with carbonates. Sodium carbonate. They react with potassium carbonate. K2CO3. See, children, another important trick I teach you. What is the compound here? Carbonate. What carbonate? We are not bothered about what carbonate it is. So, it may be sodium carbonate or potassium carbonate, calcium carbonate, magnesium carbonate, any carbonate of metal. So, what are the reactant here? Acid and carbonate, metallic carbonate. What is the product? One of the product will be carbon dioxide. Write it first, children. If the carbonate is the reactant, what is the product? One of the product is what, children? What is the one of the product? Carbon dioxide. How many? Here carbonate is CO3. CO2 is released. How many oxygen is left? One more. What are acids? Chemical dissolved in water liberate hydrogen ion. Now, is hydrogen gas is liberated? No. One more oxygen is left here. CO3, from that CO2 gone to form carbon dioxide. Who is left? One more oxygen. He combines with hydrogen to form what, children? H2O. To form what? H2O. What else is the product? NaCl. NaCl. Whenever metal carbonates react with acids, metallic salt plus water plus carbon dioxide. Additional product has come here. Additional compound. What is that? Carbon dioxide. Why? Reactant is carbonate. Similarly, no need to discuss here. Potassium sulfate. K2SO4 plus water plus carbon dioxide. Yes or no, children? So, what the product here? You can take anything. You can take anything here. Magnesium carbonate. What the product here? What the product here, children? Carbon dioxide plus water plus magnesium phosphate MgPO4 Mg. What the valence of phosphate ions, children? Here 3 hydrogen combines with phosphate ions. Yes or no? Don't get confused. Only confusion, children. Yes or no? Phosphate ions valence of 3 minus. 3 minus or minus 3? Minus 3. So, to neutralize this, how many hydrogen ions should come? Valence of hydrogen is 1. 1 will neutralize 1 phosphate ion. Now it becomes minus 2. 2 will come to neutralize 2. 1 more will remain. 3 will balance 3. Yes or no? H3PO4 is phosphoric acid. What is magnesium valency, children? We know 2. Now magnesium valency is 2. Phosphate valency is 3. Mg3PO4 twice. Reverse the valencies. You crisscross. You are studied in life class. Yes or no, children? This is about reaction of metal carbonates with acids. Even if you don't practice this also, no problem. Practice these two. More than enough. Understood, children? Third reaction with metal carbonates. Now, come, children. Yeah. What is this? Now try to balance the equation. Try to balance. Balancing of equation we studied in previous chapter. Yes or no, children? The process of making atoms of different elements, same on reactant side as well as product side. What are the reactants here? Hydrogen, chlorine, sodium and carbonate. See, look at this equation. Is it balanced? No. Here how many hydrogen atoms are there? 1. Here how many are there? 2. Write 2 here. 2 HCl. So what type of reaction is this? Unbalanced chemical equation. See, children, what the reaction of acids with carbonates or metal carbonates? It is an example of this you can give. Or what is unbalanced chemical reaction? You can give an example of this. Now balance it. 2 HCl balance. CO2 plus O, CO3. See, children, beauty of the chemistry I said. Here chlorine was single, chlorine was balanced. When you balance hydrogen, chlorine get disturbed. Now you have to balance chlorine. When balancing chlorine, sodium also gets balanced. Na2 to NaCl. Yes or no, children? This is the beauty. Whenever you take HCl, it's an unbalanced chemical equation. If you take H2SO4, forget about this. Third one, forget about phosphoric acid. Take about H2SO4, 2 hydrogen, SO4, K2, CO2 plus O, CO2. Very good, children. If you take sulfuric acid, it is balanced chemical equation. If you take hydrochloric acid, it is unbalanced chemical equation. Yes or no? Yes. So, reaction number 3. What was the first reaction? Reaction of sodium with what we discussed? Metal sodium with hydrochloric acid reacts with metal sodium. Second one, acid reacts with metallic oxide. Third one, reaction of metals with carbonates. What the fourth one? Reaction with same reaction, children, small change. That's it. Reaction with metals bicarbonate. Metal reaction with metal bicarbonate. Bicarbonate. Bicarbonate means what, children? Here one sodium goes, in place of sodium, hydrogen comes. In place of this, one hydrogen comes. That's it. Sodium, hydrogen, carbonate is nothing but bicarbonate. Bi means 2. One sodium, one hydrogen. Carbonate means both are sodium atoms. Here carbonate means what was written here? K2. In place of K2, I deleted, I erased 2, only one potassium. In place of one more potassium, hydrogen comes. That's it, children. Yeah. Look at the reaction. Look at the reaction. What happens? Now, we'll erase this. One was unbalanced. This is balanced. Now, look at the sodium, hydrogen, carbonate. You will see what will happen, whether it's balanced or unbalanced. One hydrogen, one hydrogen. Here, 2 hydrogen. Yes or no, children? Yeah. When HCl reacts with sodium hydrogen carbonate, it is unbalanced because here, no children, here it's balanced equation. I forgot here one hydrogen, one more hydrogen is there. Yes or no? H plus H, H2 balanced. CO3, CO2 plus O, CO3 balanced. Na, Cl, Cl balanced. Whenever hydrochloric acid reacts with metallic hydrogen carbonates or metallic bicarbonate. Bicarbonate is also called hydrogen carbonate. What happens? The reaction is balanced. Look at the second one, children. Sulfuric acid reacts with potassium hydrogen carbonate. Potassium hydrogen carbonate. What type of reaction? Here K2SO4 plus H2O plus CO2. It gets reversed. Now this is unbalanced chemical equation. Why? H is there, H2 plus 2 plus 1, 3 is there. Okay. Now here K2 is there. K is there. Here K2SO4. S or no children? CO2 plus 4 O. But potassium is not balanced. Right here 2. Right here 2. What will happen? Children? 2K, K2. SO4, SO4. Balanced. K2, potassium is balanced. Hydrogen, 2 plus 2, 4. Right here, 2. Right here, 2. 2 2s are 4. 2 plus 2, 4. SO4 remains same. Carbonate, 2 3s are 6. How many carbon atoms? 2. Multiply, how many becomes here? 2 3s are 6. 6 plus 4, 10. 2 plus 2, 4. 4 plus 4, 8. Right to here. 2 2s are 4. 4 plus 2, 6. 6 plus 4, 10. 2 3s are 6. 6 plus 4, 10 carbon, 10 oxygen atoms. Carbonate, 2C, balance. Yes or no? Very interesting. What the fourth reaction? Reaction of metals with bicarbonates. Or you can take it as an example for balanced and unbalanced chemical equation also. Last one, children. What is that? Reaction to metals with bases. Already we studied, children. Just for the formalities or namesake, I will write it because you are already familiar. Yes or no? Reactions of metals, acids with bases. Reactions of, I don't erase the name of this acids. Reaction number 5, what is it? Reactions of acids with bases. Which base? Strong base, I take NaOH. Acids react with bases. What do we get? Salt and water. Salt and water only. Sulfuric acid reacts with KOH. You take other base. KOH. What do we get? K2SO4 plus H2O. Yes or no, children? So, is it balanced? No. Here potassium, it's an unbalanced equation. Potassium to multiply to 2K K2, then 4 plus 1, 5, 4 plus 2, 6. Hydrogen is also not balanced either. See now, here hydrogen was 3. When we multiply to balance potassium by 2, it becomes 2K K2. Here 2 hydrogen becomes 2. Here hydrogen 2 plus 2, 4. Multiply by 2. See now, oxygen also gets balanced. That's what I said, beauty of chemistry. 4 oxygen, 2, 4 plus 2, 6. 4, 2 into O. When you multiply this by 2, hydrogen get disturbed. Hydrogen balance, well balanced hydrogen, oxygen is also balanced. This is about reactions of acids. Small topic, but I discussed at length. Why? Because you have to balance this. So this is an examples of reactions of metals, acids with bases, bases. So metallic oxides, carbonates, bicarbonates. These are examples of what? Combination reaction or double displacement reaction, not combination reaction, displacement reaction and balanced and unbalanced reactions. Isn't it, children? Yes or no? We'll go to our next topic.